Exercise 2.7, problem 16 to 20, solution. So let's get into the exercise problem 16. In a GP, T2 the second term is 3 by 5, T3 the third term is 1 by 5, then the common ratio is, we have 4 options. This is a very simple problem. T2 is given, T3 is given. And what is R? R is T3 by T2. Calculate T3 by T2 and select the option, right? Now, R is T3 by T2. In this case, T3 is 1 by 5 and T2 is 3 by 5. So, it's 1 by 5 divided by 3 by 5, which will become 1 by 5 into 5 by 3, right? So, this 5 and 5 will cancel and you'll be left with 1 by 3. And 1 by 3 is option B. Am I right? So, R equal to 1 by 3. So, it's option B, which is the right answer. Okay, right. Now let's get into problem 17. If x not equal to 0, then 1 plus secant x plus secant square x plus secant cubed x plus secant to the power of 4x plus secant to the power of 5x is equal to, we are given various options. But if you look at all these options, is basically they have taken 1 plus secant x or 1 minus secant x out, and then we got remaining 3 terms. So basically what we need to do is that this is 1 plus secant x. From these 2 terms, you can take secant square x out. So this will become 1 plus secant x. And from these 2 terms, you can take secant to the power of 4x out. So this will become 1 plus secant x. Then you can take 1 plus secant x commonly out. So this is how this problem needs to be worked. So now let's try it. So this 1 plus secant x will come down as it is. From these 2 terms, that is the third and the fourth, you can take secant square x commonly out. So what will happen? This will become secant square x into 1 plus secant x. You can check secant square x into 1 is secant square x. It's there as it is. Secant square x into secant x, that is secant cube x. It is also there, right? Now, from these 2 terms, you can take secant. From these 2, actually, you have to take one second. From these 2, actually, you need to take secant to the power of 4x. I by mistake have written secant cube x. So this is secant to the power of 4. Okay. So what will happen if you take secant to the power of 4x? So it will become the 1 plus secant x. Now you see 1 plus secant x is common between all these terms, right? So you can take 1 plus secant x commonly out. Then what will be left? 1 will be left here. Secant square x will be left. And secant to the power of 4x will come here. And if you see, this whole expression now is equal to this expression. Now, which option do you need to select? So, I think that will be 1 plus secant x into 1 plus secant square x plus secant to the power of 4x. So, that is basically, I guess, this one. Am I right? No, it is this one. 1 plus secant x into 1 plus secant square x into secant to the power of 4x. So, it is basically this option. Am I right? Yeah, that's right. So this is the one. Okay, so basically we need to take secant square x commonly out from these 2 terms and secant to the power of 4x commonly out from these 2 terms. So that is what this problem is all about, and simplifying it. Okay, right. Now let's go to problem 18. If the nth term of an AP is Tn equal to 3 minus 5n, then the sum of the first n terms is, see, sum of the n terms, they given you n by 2 or n and all these things. So we'll have to use this formula, Sn equal to n by 2 into a plus l, the first term plus last term. And how will you get the first term? By putting n equal to 1 here. So when you put n equal to 1, so this will become 3 minus 5, that is minus 2. And the nth term, we'll keep it as it is. Then substitute that values here and simplify it. You should be able to get one of these options. So now let's try that. So substituting n equal to 1, we get Tn equal to 3 minus 5n, which will become 3 minus 5 into 1 is 5, right? So 3 minus 5, that is equal to minus 2. Now let us take the last term as it is, 3 minus 5n. So this is our L and this is our A. So substituting these 2 in this formula, you should be able to get the expression, the value of Sn. So let's substitute that. So Sn equal to n by 2 into A, which is minus 2, plus n is 3 minus 5n. So simplify this. So what will happen? Minus 2 plus 3, that will become 1, right? And this will be minus 5n as it is. So the final expression or the final value of Sn is n by 2 into 1 minus 5n. So which is the 1? So n by 2 into 1 minus 5n. So I guess this is the one option which is correct. Am I right? So basically in this case we need to know this formula and substitute n equal to 1 to get the first term and keep the nth term as it is, and that is our last term. Substitute them in this formula, simplify, and you'll be able to get the value of Sn. Right, now let's go to 19th problem. The common ratio of the GP a to the power of m minus n, am, and a plus a to the power of mn is, so again it's like one of the previous problem. They have given you 3 terms in a GP and they are asking us to find the common ratio. So it is this term minus divided by this term or this by this. So it will be common term r will be a to the power of m divided by a to the power of m minus n, or a to the power of m plus n divided by a to the power of m. So that is our common ratio. So that is what T2 by T1, which is a to the power of m divided by a to the power of m minus n. So what's our formula? A to the power of m divided by a to the power of n equal to a to the power of m minus n, right? So this will become a to the power of m minus, you have to put this inside bracket, but I have done it straight away. So minus into m minus n. So this will become minus m plus n, or when you take it up, this will become minus m plus n. So this m and m will get cancelled. So you will be left with a to the power of n. Now let's try T3 by T2. Then only you can confirm it, right? So this will be a to the power of m plus n divided by a to the power of m. So this will be a to the power of m plus n minus m. Again, this minus m and plus m will cancel. So you will be left with a to the power of n. Therefore, the common ratio r is a to the power of n, which is option C. Alright. So in this case, all you need to know is that r is T2 by T1 and T3 by T2, and you should know this basic indices formula. Okay. Right. 20th sum. If 1 plus 2 plus 3 up to n is k, then 1 cube plus 2 cube plus 3 cube plus n cubed is equal to, they have given us various options. We know 1 plus 2 plus 3 up to n is k into k plus 1 by 2, and the sum of cubes is nothing but sigma n the whole square, right? Sigma n equal to n into n plus 1 by 2, and sigma of n cube, that is 1 cube plus 2 cube plus 3 cube, is n into n plus 1 by 2 the whole square. But in this case, the sigma n is, what have they given? They have given that it is equal to k. So this is k. Okay, and what is this? It is basically, or okay, from these two, what is the formula which you can derive? That is sigma n cubed equal to sigma n the whole square. So that's all in this case. But what is sigma n in our case? That is k. So sigma n cubed will be k square. So which is basically option A. You got it? So 1 cube plus 2 cube plus 3 cube plus n cubed will be, that is sigma n cubed. Sigma n cubed is sigma n the whole square as per this formula. Using these two formulas, you can make out sigma n cubed is sigma n the whole square. Am I right? This is n into n plus 1 by 2, whereas sigma n cubed is n into n plus 1 by 2 the whole square. Right? So it's basically this square. So sigma n cubed will be sigma n the whole square. So that is what I've written here. So now you substitute. Sigma n is nothing but k. So sigma n cubed will be k square. You got it? So it's basically option A. Right? So that is all in this problem. So I hope it's all clear. If not, please go through this one more time. It will become clear. Thanks for watching this video.